Y'all, I had a plan. Do you remember my plan? My plan was this stuff, which we're still going to do and we still need, and is still mostly unrelated to Media Over Quick. But I had a plan, and my plan was we're going to do this. We're going to standardize Stupa and Muxle, and then we're going to use that standard, and we're going to embed atproto data in there, which we already do, actually. We embed your atproto live stream and everything in the streams that you do. Oh, my mic's turned way down. Hold on. There we go. And then we were going to broadcast that around, and we would have and eventually implement Media Over Quick. So we were going to have atproto on MP4 files on Media Over Quick, and it was going to be like a really cool other way to broadcast atproto stuff around attached to a live stream. Yeah, they just did it. So the thing that actually got me excited enough to do this is an IETF draft. I'll explain what MoQ is in a second, but this is an IETF draft. A filing that sort of goes alongside with the atproto IETF working group that Brian and them are in the process of putting together. And it's from two Cisco engineers. So you've had this sort of recurring atproto problem where it feels like it hasn't been taken seriously on some certain levels. Let me tell you where they are taking it seriously is at Cisco, apparently, who make most of the routers that make up the internet. Because in an official capacity, these two just published a draft for atproto over Media Over Quick. So I can explain what that is quickly. Atproto over Media Over Quick, and then Media Over Quick is over Quick. So let's talk about Quick. Quick is HTTP 3, the third version of the big hypertext transfer protocol you all use to download files over the internet and post bad memes and whatnot. There's chat. Yeah. Dorian's explanation is good. Binary HTTP over UDP. So HTTP 3 finally throws away TCP sockets that have been keeping it slowed down for a variety of ways, and moves to, since the original invention of HTTP in 1990, we've come a long way on figuring out how to multiplex lots and lots of data over the internet. We do it over UDP sockets. We get our consistency guarantees from well-crafted protocols rather than from the inherent properties of a TCP socket, where if you're confident every byte arrives in the same order, right? A lot of the internet uses this now. In Chrome, Quick is used by more than half of all connections to Google servers, for example. Right. Then Quick is HTTP 3. There are differences between Quick and HTTP 3. I don't know what they are well enough to tell you what they are. They are closely related to each other, but they are technically different things. Then on top of that, you've got Media Over Quick, which I know some about. I'm actually not like a huge expert in Media Over Quick. I do, however, know a lot of video engineers, and I can tell you all of them are very, very excited about Media Over Quick, which is using the same technology to make video go, both in sort of a replacement for, you saw Cloudflare do a big Media Over Quick announcement, And so in this case, it's sort of a replacement for big HTTP CDNs that you used to see distribute video over the internet that needed caching properties and stuff. This is like the basis of Cloudflare's quick relay thing, which looks pretty cool. Cloudflare MoQ relay. Yeah, this thing. No. Maybe? I don't know. So it's a replacement both of that and of WebRTC, which is, if you're watching this stream, you're almost certainly watching a WebRTC stream, which is the technology we developed that also uses UDP, but a different transport layer stack entirely, and was designed, of course, for video calling, going back and forth. So I had this dream that in the future we might do atproto over Stupa segments over media over quick. And now probably not going to do that. It might do something similar, might multiplex it. So now we have from two Cisco engineers atproto over MoQ Transport. I didn't really know about, I knew about quick transport, like backing like web transport streams, and I knew about media over quick. I did not know about quick transport or MoQ-T. It sounds like what HTTP3 would be, but I'm sure it's different in ways that we'll find out. So a lot of you in the chat are saying that a lot of people didn't really know what to make of this. I'm in over my head too here. I know everybody's excited about it. I understand some of the properties. I can't give a technical overview of it. So we'll see how deep we go in this. I don't know if I'm going to do a read along of the whole thing, but we'll certainly do the abstracts and take a look at everything. I mean, it's not that long. We could maybe do this whole thing, but yeah, like for this coming out of Cisco, an enormous company, it's just a huge ecosystem deal, I think, for like Cisco coming out of an enormous company. This is like the first I'm going to say like very serious low level sync architecture thing that I've seen come out of anywhere other than Blue Sky, and it's coming out of fucking Cisco. So okay, hell yeah, let's go. Hey, Boris said he couldn't log into Streamplace. Did anybody else? Obviously, don't tell me in chat, but Blue Sky at me or something if you're having trouble logging into the stream. We did release an earlier version today. I was able to just log in, but it failed the first time, and then I had to try again. So we might have a bug there. Please let me know. Yeah, big Monday for the protocol. Adam. There's been one or two things named that before. Adam, at Protocol Over MoQ Transport. This document specifies how the authenticated transfer protocol can leverage media over quick transport for efficient data synchronization across decentralized social networks. The at-protocol's firehose event stream and repository synchronization mechanisms match naturally to, I'm going to pronounce this MoQT, I guess, to MoQT's publish-subscribe model, enabling scalable relay infrastructure, priority-based delivery, and improved resilience for large-scale social data distribution. This specification addresses the challenges of the current WebSocket-based transport and demonstrates how MoQT's relay architecture, group-based caching, and multiplex streams provide significant benefits for at-protocol deployments at scale. Sorry, I'm very excited and tripping over my words a little bit here. Anybody say oh, hey Richard, you're in chat. Hi. MoQ is basically pub sub point to multipoint where each link in the tree is quick. Right. Yes, got it. Inspired by named data networking / information-centric networking. Very cool. Richard, I don't know if you can, but I'd be really, it's super cool to see this coming out. I'd be curious if you could say anything about like how this came to be. And I know you've been a participant in. I know you've been like around for some of the IETF atproto stuff. So yeah, very cool to see this come out of here. Sure. I'd love to. Yeah, can set that up anytime you want. Yeah. We'll go through this a little bit further now, but yes, let's absolutely. Let's see. Can I Blue Sky DM you? I cannot. Yeah, reach out over something and we'll figure out a time. Blue Sky DMs, or I'm Eli on Discord, or you can really easily guess my email address because it's my first name and then an @ symbol and then the website you're looking at. Good application. Thank you, Ted. Yep. Good application layer broadcast with backfill is basically the intuition to have. Got it. Cool. Yeah, that makes sense to me. That makes sense because people do seem to play up the MoQ as a replacement for like big HTTP like caching CDNs that you'd see for really, really big live streams at scale. Status of this memo. I'm not going to read the status of this memo. Copyright notice. Copyright IETF trust, blah, 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 blah. Here we go. The Authenticated Transfer Protocol, ADARC, provides a framework for decentralized social web applications using self-certifying data repositories. The protocol enables users to maintain control over their data while participating in a federated network of personal data servers, relays, and application views, app views. Currently, atproto relies on two primary transport mechanisms for data synchronization. HTTP, used for batch repository exports via CAR, content address archive files. WebSocket, used for real-time event streams, Firehose with CBOR encoded messages. While functional, these transport mechanisms face significant challenges at scale, particularly for the Firehose event stream that must distribute updates across a network with millions of users, generating billions of records. Yes. I have spoken to Blue Sky engineers that were surprised at how far they have managed to ride WebSockets off into the sunset. We were always going to need something else. Didn't really expect it to just show up in Blue Sky notifications today, but there you go. This document defines how media over quick transport, MoQ transport, can serve as an enhanced transport for atproto. MoQ enables low latency delivery, while relay caching supports multiple latency spectrums from real-time to eventual consistency. The protocol's native publish-subscribe model, relay infrastructure, and priority-based delivery address current scalability and resilience changes. Cool. Atproto architecture. Everybody good on this? There's PDSs. You're all on one right now. Relays, collect them, and they go to app views. Cool. You're looking at an app view right now. I think it's I know Paul posted it's probably time for us to get rid of this term. I think that ship has probably sailed. Is it an IETF draft from Cisco, for Christ's sake? What are you thinking? Yeah, I'm warming up to it as well. The current architecture comprises personal data server, hosts user accounts and their data repositories. Each PDS provides a Firehose endpoint for real-time updates, and HTTP endpoints for repository exports. Relay aggregates Firehose streams from multiple PDS instances into a unified event stream. Full network relays attempt to include all PDS instances in the network. And AppView, application-specific indexing services that consume the Firehose to build aggregated views, e.g. feed, search, analytics, or, live streaming in our particular case. Requirements language. The keywords must not require, shall not, should not, recommended, not recommended, may, and optional may, and the option may interpret to be before. Challenges with current transport. The current WebSocket-based transport for atproto faces several challenges that impact scalability, reliability, and operational efficiency. Scalability limitations, connection overhead. Each subscriber to a PDS or relay firehose requires a dedicated WebSocket connection. At network scale, this creates connection state overhead on servers hosting popular content, TCP head-of-line blocking, affecting all events on a connection, and limited ability to prioritize critical events during congestion. Yes, so this is basically the issues that basically what people like about HTTP 3 over HTTP 2, right? You've got a lot of state to keep in your head, which means overhead on, in particular, Cisco routers. TCP head of line blocking means if one particular thing is coming back slowly, there's a lot blocked behind that can slow down you loading a web page. And limited ability to prioritize critical events. So if there's a lot of data happening, you won't prioritize effectively. So a lot of these are what you would want from a big media network too, right? In particular, like you can imagine if I'm doing a big global live stream, the highest priority pieces of video would be the lowest quality. So if all else fails, you get this really low quality video if we're under congestion, but everybody still gets to watch the stream, as opposed to we serve much higher quality video to nobody because there's network contention, right? Message size constraints. The current protocol specifies a hard maximum of 5 megabytes per WebSocket frame. While this accommodates most operations, it creates challenges for large repository commits, limited to 2 megabyte blocks or 200 operations, efficient batching of small updates, and variable size content distribution. Yeah, I guess all I can say is we really expected them to. They will be eventually, and we really expected them to be by now. Especially the WebSocket based stuff. I'm also surprised we've got. I mean, Streamplace does WebSockets for like MP4 replication right now. It's all kind of, from somebody with your background, kind of ridiculous architecture. They were going to be issues. This feels like we're skipping right to the end. Where instead of doing a bunch of other protocols, let's just do something very much like this and be done with it. We've got a single stream bottleneck here. Current Firehose, single stream for all event types, WebSocket connections. So there is, when you open up a WebSocket, you get a series of things in order. You don't get lots of things coming from lots of different directions with the ability to prioritize the things that are most important, right? All event types, probably this is about what I just said. All event types flow through a single WebSocket stream without differentiation, meaning high priority identity changes wait behind large commit events. Account status updates cannot preempt in-progress transfers, and there's no mechanism for subscribers to filter by event type at the transport layer. We've got reliability challenges. Cursor-based replay limitations. The current Firehose relies on monotonic cursor values for replay after disconnection. This approach requires consumers to track cursor state externally, since the protocol provides no mechanism for server-side cursor persistence. Gap detection depends entirely on commit chain validation, which is computationally expensive and requires maintaining local state. When gaps are detected, recovery requires fetching the complete repository, creating a thundering herd risk when many consumers reconnect simultaneously after an outage. This is the first one I'm not 100% sure. I'm not 100% sure that's right, because there's a Merkle tree diff that happens when you request this. But if you're not storing the repository locally, yeah. In that case, you definitely would need to. I think you would need to reingest everything to get back there. If you have a copy of the repo locally, then you can do a Merkle tree diff, which is much more efficient. No native late join support. When a new consumer connects to a Firehose, it must either start from the current position and miss all prior events, or replay from a cursor to catch up. There is no concept of recent state that would allow quick synchronization to a meaningful starting point. Consumers cannot receive cached recent events without initiating a full replay sequence, which increases latency for new subscribers and places additional load on the server. State quick synchronization. Interesting. I am interested. Problems I didn't realize would be addressed by this proposal is how I would characterize both of these. Yeah, makes sense. Connection fragility. WebSocket connections over TCP are susceptible to network path changes that cause connection drops. The protocol provides no mechanism for connection migration when a client's IP address changes, such as when moving between networks on a mobile device. Any network transition requires establishing a completely new connection and resuming from the last known cursor position. True. So this is moving between networks on a mobile device. This gets cited as something we can do better with IPv6. This gets cited as, yes, quick, and to some extent WebRTC are both capable of handling this situation where you, I forget the terminology. I think of it as the riding a train. If you're riding a train on a phone before any of this technology existed, even if you were always in cell service, your connection was going to get severed and brought back if you were going over a TCP socket. Richard said, in principle, quick connection IDs handle multipath. Not sure if it's actually supported in practice. Okay, yeah. I also, wouldn't really know. Yeah, this is one of the things. If anybody in the room has tried running a Streamplace node, one of the annoying things is you have a large range of ephemeral UDP ports that you have to open up on your firewall for all the different WebRTC connections coming in. There are ways around this, but the reason that they do that is to make it easier to resume the connection if the client IP address changes or the connection is otherwise severed for whatever reason. And Quick makes that better. Operational challenges. Relay infrastructure complexity. Current relays face significant operational burden in maintaining the firehose infrastructure. Each relay must establish and maintain persistent WebSocket connections to all upstream PDS instances it aggregates, scaling linearly with a number of sources. When connections fail, relays must handle reconnection logic and cursor tracking independently for each upstream source. Custom caching and replay logic must be implemented at the application layer, as the transport provides no native support for these operations. Additionally, relays must build proprietary distribution mechanisms to serve their own downstream subscribers, duplicating effort across the ecosystem. This is sort of a reference to Rainbow, which is Blue Sky's relay fan out service, essentially. Limited quality of service. The current transport provides no native mechanism for quality of service differentiation. All event types receive equal treatment regardless of their operational importance, so critical account status changes compete with routine content updates for bandwidth. Rate limiting based on consumer capacity must be implemented entirely at the application layer, with no transport level flow control. Graceful degradation during overhead conditions is difficult to achieve, also often resulting in connection failures rather than controlled service reduction. Yes, there's a relay bug right now that everybody runs into sometime where the relay cuts you off because you are not consuming events fast enough, and the outgoing events are just backing up in memory on the relay side, and the relay cuts you off. But I think the bug is that it doesn't sever the TCP connection, so you just end up with an open socket to nothing. Something like that. Yes. Definitely. That one, definitely a pain point. Especially as regards, like consumer not consuming data fast enough. 3. All right. Summary of section 2. Yeah, I think most of those are problems, and I'm surprised to hear this one proposal can address them all, so let's go. 3. MoQ transport benefits. MoQ addresses the challenges identified above through its native architecture designed for large-scale media distribution. 3.1. It has a native publish-subscribe model. MoQ's publish-subscribe model aligns naturally with atprotocol's firehose semantics. Subscribers select specific event tracks of interest, while publishers announce available tracks via publish namespace. Since relays handle distribution, no dedicated connection is required per subscriber, and track-level subscription granularity reduces unnecessary traffic. Publish namespace enables dynamic discovery of available content. When a PDS comes online, it announces its namespaces to connected relays, advertising firehose tracks, repository sync tracks, and blob stores. Relays learn about new PDS instances automatically without static configuration, enabling the network to scale organically as new servers join. Very cool. Yeah, big distributed pub subsystem is the impression I'm getting of this. Finally, subscribe namespace allows subscribers to discover available tracks using prefix-based queries. A full network relay can subscribe to @firehose. This is syntax? Oh, this is like prefix-based syntax. Oh, these are the namespaces. Got it. @/firehose to discover all PDS instances publishing firehose events. Then selectively subscribe to each. An app view could query a relay's namespace to enumerate available event types before subscribing to specific tracks of interest. This discovery mechanism enables the need for out-of-band coordination when adding new publishers or subscribers to the network. Okay, very cool. And I see firehose events from this PDS, repository stinks class, blob storage. That's potentially interesting. Yeah, my impression actually was we were just reading Paul's blog post about what's the terminology he uses? Yeah, federated. So we've gone with federated hosts and magical meshes, and atproto doesn't quite fit into either of them, but this feels a lot like infrastructure that would be closer to a magical mesh version of the world, where you have this seems like a pretty dynamic protocol scape that would be capable of syncing in lots of different directions. I'm not sure about private data immediately. The whole thing behind MoQ's media publishing is that you would be able to do like cached, replicated, big public broadcast really well. So I'm not sure if it would immediately be useful for that, but you can imagine. I mean, yeah, like however it works, you can imagine it working with this. A PDS. I read that part already. A relay discovering PDS instances issues subscribe namespace with @firehose and receives a namespace response listing all matching hosts, potentially thousands of PDS instances. Hey, Trezzy. Yeah, this is, we got a big atprotocol IETF proposal from a couple of Cisco engineers. That shit's never happened before. 3.2, priority-based delivery. MoQ's 0 to 255 priority scale enables differentiated event delivery, ensuring that critical account takedowns, priority 0 to 15, and urgent identity changes such as key rotations, priority 16 to 31, are delivered ahead of routine commit events, priority 96 to 191. Whoa. This prevents large content transfers from blocking time-sensitive operations, rather. Ooh. MoQ working group as work in progress. I heard that actually. Yeah. And key management TBD is sort of the story of a lot of these projects. I gotta turn the lights on in here 1 second. Key management TBD. Yeah, just put them all on a big website called plc.directory and Worry about it later. So we've got different priorities for different Firehose event types, which is very cool. So we've got account events. This is like takedowns and whatnot. We've got identity events, key rotation, handle changes. Yep, you want to figure that out pretty quick. Account events, account state changes. I don't remember what those. Oh, I see. This is takedown and then account status. Takedown gets the highest priority in mocked. Sync events is state resets. Typical record operations of small commits. Not even most commits are people liking a blue sky post that doesn't even come close to approaching the maximum commit size. Got large commits. These are background bulk content updates, and then repository export. So these would be full sync operations. That's interesting. So you can imagine this last one, like exclusive, all backfill happens way down here at the bottom of the priority chart, using the rest of the available bandwidth. Very cool. You could have something like the PDS hand out a key over HTTP, then blast out the encrypted clients over MoQ. Yeah. Yes, welcome. Welcome to atproto private data design. We propose a lot of sort of mechanisms like this. Relay. Okay, yeah, very cool. Sold on this. So this is, yeah, I mean, this you can imagine. You can imagine this supporting maybe better than the existing WebSocket stuff. So the thing we don't talk a lot about these days, because we're not going to need it for a long while, would be like sharding. When it is truly, so we've got like a 5-ish megabit Firehose, I think, last time I checked, that order of magnitude anyway. When it gets to like 50 and then 500, and now it starts to become infeasible to use a 1 gigabit Cat 5e cable to sync the whole network, then you need to talk about splitting it out into different ingest nodes, all handling some different prefix encoded part of the Firehose or something like that. And you can imagine something like this being really useful for implementing something like that as well, where you can subscribe to different pieces of it. Hey, that's how I feel about PLC directory too. Less bad than you'd think. Relay infrastructure. Mocked relays provide purpose-built infrastructure for at-protocol distribution. Hierarchical relay topologies reduce origin load by distributing cached content from regional nodes, while geographic placement optimizes latency for subscribers. Because the relay protocol is standardized, operators need not implement custom distribution logic. Cool. What? Cool. That's I don't know. I guess I've built too much of my life on HTTP, so it's just like, what are like the endpoints for it? But no, it's just a protocol. What? The real question, I don't know. What level of the OSI model are we talking about here? I don't really. Quick, because I know Quick is one level below. HTTP 3 is one level below something else. Not even sure. Yeah. PDSs go to all of those. But yeah, you can imagine where we would subscribe from regional real. This actually, I was just describing like sharded consumption of gigabits of Firehose data. This is sharded, or not sharded, but like regional aggregation from PDSs, basically. 3.4, group-based organization and caching. Mocked groups enable efficient caching and late join support. Late joining late join. I get it now. My head interpreted the word join as a SQL kind of like joining data later. But no, this is you showed up later. Mocked groups enable efficient caching and late join support. Late joining subscribers receive the most recent group immediately, rather than replaying from the beginning, and relay caches at each tier reduce upstream load. Group boundaries serve as natural replay points, with cursor semantics mapping directly to group ID and object ID. Okay, now we are into terminology I don't know, but quickest transport layer. Yeah, that makes sense. That makes sense to me. Late joining subscribers receive the most recent group. Got it. Yeah, I can upload one, Ted. I can do that. Yeah, cool. Late join via subscribe. MoQ's subscribe message includes filter parameters that control the starting position for delivery. As defined in MoQ Transport, these filters include latest group, start from the latest available group, latest object, start from the most recent object, absolute start, begin at a specific group object position, and absolute range, request a bounded range. These filters allow subscribers to join at any point and then continue receiving live and future content. Very cool. Yeah, my brain, of course, translates that into like HLS playlists right away. But there's going to be a lot of cool ways to do it. Subscribe delivers content from the specified starting position forward, keeping subscribers at the live edge as new content arrives. For historical content retrieval, subscribers use fetch operations instead. See section blah. On-demand retrieval. Cool. Historical content retrieval. I also model the world in terms of all VOD is just like a live stream that happened a long time ago. I know you might not use all of this for VOD playback, but you probably will, and it'll probably be great. This capability supports several @protocol scenarios. A new subscriber joining a track uses latest group to begin with the current activity. 342, fetch for on-demand retrieval. MoQ's fetch operation complements subscribe by enabling selective retrieval of specific objects. While subscribe keeps clients at the live edge, fetch receives historical content regardless of how far back it exists. Fetch specifies exact group and object ranges, retrieving precisely the needed data without establishing a continuous subscription. Cool. Yeah, I mean, we were just talking about how we're going to implement VOD, or what video engineers call DVR, right? Like rewinding the live stream you were just watching and coming back. When a subscriber detects a gap in received events, it can fetch the missing objects directly rather than replaying an entire group. When verifying a specific record, a client can fetch just the MST block paths needed for cryptographic validation. For deep historical queries, an analytics service can fetch specific commit ranges from months prior. Very cool. Okay, so this is exactly what I was just talking about. MST path blocks. That's interesting. I would be curious. We're now at the bleeding edge of my knowledge of atproto sync semantics, but I would be curious to know about the relationship there between MST like MST nodes and the fire hose, the events that go out over the fire hose. I guess I know it attaches a group of them. I'm just wondering about like, I guess what I'm getting at here is, can you like play the fire hose through one of these mocked atproto relays and then later come back and do some sort of MST sync for a specific thing? I'm not really sure without keeping a full copy of the local repository. Relay caching amplifies the benefit of fetch operations. Popular content such as viral images, high-profile account commits, and frequently accessed MST nodes remain in the relay cache. Subsequent fetch requests for this content are served locally, reducing latency and eliminating load on origin servers. For a viral post with an embedded image, thousands of fetch requests for an image blob requests resolve to a single origin fetch followed by cache hits at the relay tier. Yeah, this is the first I would need to like really turn my head sideways and remember how all of this works. But when I do a proper, discounting like Jetstream and stuff that strips the signing data, which makes my decentralized heart sad. This is, sorry, I've got Discord channels popping off here that I'm going to mute. Thousands of fetch requests. So when you do that, when you make a request to get record, I think atproto sync get record, the thing that you are given is I think a freshly computed MST proof. And I'm not sure if you could, absent keeping a copy of the repository locally, I'm not sure if you can get there just from Firehose data, which might be problematic for this caching mechanism, but my head's starting to hurt even just loading that all into RAM. So that's the only immediate thought I have there. Sounds good. It sounds good. You can imagine a world where that you'd be able to do all of that, but it would be something a little bit more intensive on the application layer, where it's like keeping the MST or a portion of it in memory so that it can serve this stuff, as opposed to just like merely retransmitting Firehose data, right? 343 caching benefits summary. The combination of subscribe, late join, and fetch with relay caching provides several benefits for @protocol deployments. Fan out efficiency. Origin publishes once, relay serves many subscribers. Late join speed. New subscribers received cache history immediately. Gap recovery. Missing events fetched from relay cache, not origin. Popular content, high demand blobs and commits served from cache. Reduced origin load. Relay tier absorbs read amplification. The mention of blobs in here, I don't think there's there's like almost nothing particularly creative happening with @proto blob sync right now. It's very much just like pull them when you need them, and there's like caching layers in different places for certain. Yeah, if they're I wouldn't assume we I feel like if we are generalizing this to blobs, we would need to there would need to be like a section that explains how that works. Maybe there is. I don't know. I just wouldn't assume you would necessarily automatically have it happen from the Firehose. But here's a blob store track. So hang on. Let's soldier onward. Quick transport advantages. Leveraging Quick provides connection mitigation. No. Leveraging Quick provides connection migration so that Firehose subscriptions survive network changes such as IP address transitions or Wi-Fi to cellular handoffs. Multiplex streams eliminate head-of-line blocking between logical channels, while mandatory TLS 1.3 ensures built-in encryption. Per stream and connection level flow control prevents subscriber overload, and zero RTT resumption enables fast reconnection after brief disconnections. In short, Quick, good. Love it. Okay, so now continue to blow my mind a little bit here. Mocked mapping. This section defines how @protocol data maps to mocked primitives. 4.1 connection establishment. @protocol endpoints using mocked established connections following using the standard mocked setup procedure. We have... Okay, yes. I do know this part. You can specify different IDs here. So there's mocked client setup, relay capabilities, publish namespace, subscribe namespace. Okay. These are subscribe, commit, subscribe. Okay. Okay. Namespace tracks available. Okay, this concept of a track is going to be interesting. Set up parameters for @protocol. We've got an at protocol version, at supported events, which is a bit mask of supported event types. Interesting. And at relay caps, which is relay capability flags. Okay. So we've got bit mask based extensible system in here. Register of track identifiers priorities. Yeah, we have the priority. Right. Yeah, the priorities are up here already. But yeah, I think we're just going to get to track types then. Oh, we've got the priorities again down here. Event type bit mask values, 1 for commit, 2 for identity, 4 for account, 8 for sync. Oh, you can have more than one? I guess you can, can't you? Yeah, you can. I never see it, but you totally can. Oh, yeah. Track types. Adam defines 3 track types for different use cases. 421 Firehose tracks. Firehose tracks carry real-time event streams from PDS hosts. Namespace structure at Firehose host, event type, DID, or all. Cool. We've got commits, identity, account, and sync events. They all have. So this is interesting. So this is almost like an alternate. I wonder if this like namespace generalizes all the way to the point that we would of at URIs. Like one could imagine. So something interesting that you can do. So say for the sake of argument that I'm a chat app and I only care about my play stream. I only care about play stream chat message records from a certain user. You can subscribe to that, and you can get like an authenticated stream of that. That you get proofs of only that part of the Merkle tree, and you don't care what's in the rest of the Merkle tree. You can imagine a syntax of this where you would drill down all the way down to the level of individual connections. You know, years down the road when we've all got 5 terabyte atproto repositories or what have you. Yeah, I think it's just interesting to know what you can sync in an authenticated way and what you can't. All of my all entries in a specific collection of mine, no problem. Everyone's chat messages in this particular live stream, much larger problem because they're proofs coming from a variety of different repositories, right? Tracks are basically the unit of subscription. That makes sense. I assume also that they would then map to tracks. I mean, Media Over Quick was invented for media that has media tracks. That makes sense as well. Groups organize events by sequence number, 1,000 events per group. Track name is either specific did. Track name. Okay. So different from namespace is a track name is either specific did or all for aggregated streams. Interesting. This feels like the kind of thing that would get bike shedded a lot in an IETF draft kind of thing. Getting an NSID subset stream is tricky, and I know some Blue Sky folks are skeptical, but I think it can work. The problem is you end up with a stale root node for any update in another collection. Right. Ooh. You can accept having stale roots, still valid proofs but old, or transmit upper loads and not, high overhead, or something else clever. I have some ideas. I am glad I said that out loud. I said it as an example of here's something you can't do with that proto, and then maybe it turns out you can. Love it. Okay, these are repository sync tracks. Repository sync tracks provide full level, block level repository data. I mean, spoiler alert, I'm going to want to combine these with actual media tracks for getting the rest of your live stream. I thought I was going to do it by embedding the live stream in the MP4 that we're transmitting, but now I think there's going to probably be a different way. So their namespace is at repo host did sync. I'm curious about host in all of these. considering, yes, you would want, I mean, there's a canonical host that is the store of the PDS, but as soon as it leaves that host, it's supposed to be, self-certifying. So, I would assume host in this case as in PDS. I guess I don't know. I guess I'm not sure what that means. I probably might. I might know what it means if I spoke quick mock namespace, but I don't know. Because you wouldn't want to invalidate, because you can migrate from one PDS host to another without any change whatsoever in the Merkle tree structure. Right? So, you wouldn't want to invalidate all of anybody's events unless you had to. Unless it was actually like an adversarial migration or something, and they're, I don't know, starting with an empty repo, or I don't know. I don't know what we would be talking about there. The mocked hierarchy. Mocked has a hierarchy, I guess, and it maps to these atproto repository concepts. We've got a track, which maps to a repo. That's a subscription unit. We've got a group, which maps to commit or revision, which maps to temporal progression. Okay, that's interesting to me. Oh, subgroup collection plus MST path. This is exactly what I was just saying for structural organization. And then an object, which is a record or block, individual data items. The part I'm curious about here is, it sounded like from how it was talking about groups earlier, it's like, well, we get around cursors by like replaying at the group level, but this is like you get this changes every time this changes, unless you batch a bunch of changes into one event, but nobody does, into one commit rather. Maybe that works. I just haven't wrapped my head around it yet. Each group represents a commit. Subgroup 0 contains the signed commit and MST structure. Subsequent subgroups contain collections with MST proof paths for independent verification. Yeah, that makes sense. Group object naming literally comes from VideoGop. Yep. Objects within a group are ordered. Signed commit, object ID 0, MST root, MST intermediate nodes, then records. The @block SID extension header carries the SID for integrity verification. Okay. Well, I see, I have my answer as to how this was going to be able to handle all of those problems, and because it's mapping pretty much the entirety of IETF standardized atproto onto this. I haven't wrapped. I think I would need to have a little more familiarity with the underlying thing to have I can't weigh in on the difference between a group and a subgroup. But I guess this stuff might conceivably provide an answer for my my questions about the interaction between the fire hose and the MST structure, right? It's a problem with reacting to these things live, is there's sometimes answers further down in the document. Each group represents a commit. Subgroup 0 contains the signed commit and MST structure. Subsequent subgroups contain collections with MST proof paths for independent verification. MST proof path for independent verification is that describes what you get in a firehose commit. Yeah. Object subgroup 0 commit. Okay, so the signed commit and I might not speak MST well enough for this. Full MST verification anchor. I think that would just be the commit block, and then the proof path gets you to the rest of the collection. Not sure. Objects within a group are ordered. Signed commit, object ID 0, MST root, and MST intermediate nodes, then records. The @block SID extension header carries the SID for integrity verification. Okay, we've got an extension header. Remember earlier when I said this is where you were going to start to lose me? I wasn't sure how far through the document we were going to get. We got about here. And now I'm very excited, but don't speak mocked well enough to comment on whether it's appropriate to have each of these be subgroups. But if I'm taking the impression out of it that like with this subscription syntax up here that I could subscribe to subgroups, then I would love to do that. That's exactly like the chat app use case I was describing above that only cares about a portion of a user's repo. If the implication here is that I'm going to be able to figure all of that out, cool. Yeah, love it. The MST proof path included with each record contains the minimal set of tree nodes required to verify that record's inclusion in the commit. This enables independent verification of individual records without downloading the entire repository. Also, inductive fire hose operation inversion. I still don't fully understand that. Maybe the 3 people in the world that can comment on the connection between this proposal and Sync 1.1. Then we've got a blob store track. All right. Blob store tracks enable cross-repository deduplication of large media. Namespace @blobshost. The group ID is derived from the SID, first 8 bytes of multi-hashes uint64. Object ID is always 0. This deterministic mapping ensures identical blobs from different repositories resolve to the same mocked location. That's cool. You can slice as granular as you can make the tracks. Got it. Okay. Yeah. Got it. Yeah, that's basically what I was talking about up there earlier. Well, I can tell you right now that my work now is to so the work we were doing with this Stupa and Muxel stuff, which is here, is a little bit to try and make some of these video primitives work more natively with content addressing and not just have them treated as completely opaque blobs. Yes, figuring out how that world would where we're doing that using media over quick in the traditional sense to broadcast video and audio would then interact with this blob store track thing is something I would love to figure out with everybody in the future. Sounds cool. Object structure. Protocol events are encapsulated in mocked objects. Mocked object structure, extension headers, @event type, @repo DID. Okay, @event type is an integer, @repo did is a string, @repo rev is a tid, @sequence is a varint cursor equivalent, and @blocksit is bytes for repo sync blocks. Okay, that's interesting. So that's more like backfill. Or that's more like getting the MST. No, for repository sync blocks. I'm sorry. So for the hashtag sync, these things that would invalidate your tree and make you resync and that sort of thing, I think. Got it. CBOR encoded event. Subscription and filtering. Firehose subscription. Subscribers specify start position filtering, start group latest, start group N, resume from specific cursor position, track name all or specific DID for filtering. Hey, you've got the existing subscribe repos WebSocket endpoint beat already because you let me filter by one DID. I don't think you can do that with the existing one. Repository sync. Subgroup filtering enables selective synchronization. Selective sync, full repository, posts only, and verification only. So that's okay. Subgroup filters. Okay. Right. Oh yeah, so subgroup. Which one of these were subgroups? We've got collection. Yeah, collections are subgroups. Okay, yeah, that's awesome. So this is like a better design for, or at least a more feature complete design for the existing WebSocket endpoint. Yeah. Yeah, if I understand this correctly, you can filter by event type and still get a proof, which is cool. So full repository posts only. So this would be, I might write this as app.bsky.feed.posts only. And then verification only, which I guess gives you just subgroup filter 0, which is the Merkle tree root. Okay. I wonder if there's use cases there. You can do temporal navigation with groups, subscribe to start group latest, and fetch start group N and group M historical range retrieval. Late join and catch up. New subscribers request start group latest to receive current state immediately. After disconnection, subscribers use fetch with their last known group to retrieve missed commits before resuming live subscription. Yeah. Backfill, but all over Atom, as opposed to going back to a user's PDS or playing it back. Well, not just playing it back from the relay, but figuring out the interaction there. Very interesting. Okay, very cool. I got a little lost. Repository sync. We did that. Late join and catch up. Priority and parallelism. Mocked priority enables efficient delivery ordering. The reason I got confused is because this table is not this table, and I was convinced that I had scrolled back up somehow. Got it. Content addressable blocks enable parallel fetching across quick streams, with total transfer time bounded by the slowest stream rather than the sum of all transfers. Quick good. Relay aggregation. Mocked relays aggregate Firehose streams from multiple upstream sources. We saw this before. Relays perform subscription aggregation, namespace republishing, event caching for late join, and deduplication. Okay. Reliability and recovery. Atom leverages Mock's group-based delivery model and Quick's transport features to provide robust reliability mechanisms for at-protocol data synchronization. The key capabilities include cursor mapping that translates at-protocol sequence numbers to mocked group object positions, gap detection that identifies missing events through sequential object tracking, and multiple recovery strategies ranging from targeted object fetches to full repository synchronization. Quick's connection migration further ensures that subscribers maintain continuous delivery even when network conditions change. 5.1 Cursor mapping. At-protocol cursors map to mocked group and object identifiers, establishing seamless translation between the existing cursor-based replay mechanism and Mock's hierarchical addressing. Each Firehose track maintains a mapping table that records the sequence number base for each group, allowing bidirectional conversion between at-protocol cursors and mocked positions. Okay. When a subscriber needs to resume from a specific cursor position, it converts the cursor value to the corresponding group and object identifiers. The conversion uses integer division to determine the group number and the modulo operation to determine the object offset within that group. This deterministic mapping ensures that any cursor value can be precisely located within the mocked tree structure. Cool. Publishers must include the @sequence extension header in each object to enable accurate cursor reconstruction. 5.2 Gap detection and recovery. Mock's group-based delivery model simplifies gap detection compared to the current cursor-only approach. This section describes how gaps are detected and the recovery strategies available to subscribers. 5.2.1, detecting missing objects. Because objects within a group are sequentially numbered and groups themselves are ordered, subscribers can immediately identify when expected objects are missing by comparing received object identifiers against their expected sequence. Because objects within a group are sequentially numbered. And groups are commits. Yeah, okay, sure. I was thinking that objects in a collection aren't sequentially numbered, but the commit groups are commits in this case, I guess. But then subgroups are collections. I don't know how that works. Globally consistent sequence number. Well, I think it's just produced by I think the PDS is just in charge of it. I think. Yeah. Gap detection, subscriber state, last received, blah blah blah. Expected next block, incoming object block, expected, received, gap detected. And this is if you're missing commits. Recovery, fetch missing objects. The preferred recovery approach is to fetch only specific missing objects using MoQ's fetch operation with precise group and object boundaries. If relay caches contain the missing data, recovery completes without any load on the origin server. Got it. Maybe. Yes, the part that isn't clicking for me right now is the difference between replaying a fire hose and replaying missing events from a Merkle tree. This might be accounted for in something that's not clicking for me right now. If it's not accounted for, it's probably because they're treating like the fire hose data and as like a big aggregation, or like the commit objects as containing like the same data you'd need to fill in the Merkle tree later. If you're missing some commit of if you're missing some particular record. But yeah, that's as far as I'm getting with it in my head. Recovery, fetch full group. For larger gaps spawning multiple groups, subscribers may request entire groups rather than specifying individual object ranges. This approach is simpler, but may retrieve more data than is strictly necessary. Yeah, do copy that can all be cached. Recovery, full repository sync. As a fallback, when cache data is unavailable or gaps are too extensive, subscribers can perform a full repository synchronization using either HTTP car exports or the mocked repository sync track. Okay, this approach validates the entire repository state against a sync event. Yeah, that makes sense. In practice, nobody runs an archival relay, and we don't ever recover an account by replaying all of the relay events. It would always be back to the start, back to the car. But maybe that can change. 5.3, disconnection handling. Mocked over quick provides superior disconnection handling through 3 complementary mechanisms: 0 round trip session resumption, cursor-based reconnection, and transparent connection migration. Sweet. Brief disconnection, 0 round trip resumption. For brief disconnections, typically under 30 seconds, Quick's 0 RTT resumption allows subscribers to restore their connection with minimal latency. The subscriber presents a session ticket from the previous connection, and the relay resumes delivery from where it left off if the cache session state remains valid. This typically completes in a single round trip. Yeah, well, no, this is definitely this is extremely at the relay level. This is like a much more sophisticated version of atproto relays that work over media over quick semantics, which could be sick because, as we were talking about before, we have there's like a thing, the MoQ relay. There's like a product, the first MoQ CDN. Oh yeah, that's I guess what I was thinking here. This is a MoQ CDN. Does this proposal mean we can straight up run an atproto relay over media over quick CDN? Because that would be amazing. I'm assuming from mocked that we might need some more primitives, but maybe not a lot, or maybe not any, and then we could just do it and it would be really cool. I don't know. Sounds awesome. Extended disconnections, we can do cursor-based reconnection. For extended disconnections where session state has expired, subscribers perform a full reconnection using their saved cursor position. The subscriber first uses fetch to retrieve any missing events from their last known position, and then establishes a new subscribe starting from the latest group to receive live updates. Relay caches serve the historical data when available, minimizing load on upstream servers. Yeah. That's the existing one. Yeah, that's how we do it now. Cellular transitions, connection migration. For connection transitions, such as Wi-Fi to cellular handoffs, quick connection migration enables seamless continuation without any application-level intervention. The subscriber's IP address changes transparently while the mocked session continues uninterrupted, ensuring no gaps in the event stream during mobile network transitions. You're going to say to yourself, but atproto stuff mostly uses app views and these big scalable Martin Kleppmann database architectures, and they're all on servers, and servers don't swap from Wi-Fi to cellular. That's true, but also that's also because we can't do it right now. And maybe if there was a much more lightweight mechanism, especially if we're talking here about implementing some sort of sync system using that like system capable of syncing individual repositories and stuff, then yeah, maybe you'll connect your phone to a relay. Why not? I don't know. Don't assume that just because we do something right now, it has to be the way we do it forever. And that's the end for now. This is so cool. I will continue monitoring and diving into this. It's published a couple of days ago. Very, very cool. And I, down for any updates. Very excited if we can do something like that interview stream that you mentioned. Would love to do that. I mean, accelerating plans to this sort of upends everything I was planning to do. I think we do need to still standardize this content addressable MP4 container format situation, but it will certainly now be done with a much more urgent perspective of, okay, but how does all of this map onto the MoQ data structure, especially as regards like mapping individual video track, like doing media over doing actual media over quick, and then alongside media over quick transport atproto alongside Atom. Very, very cool. I've been drinking a lot of water over the course of this. That was pretty long. I need to use the bathroom. I leave you all with Pokemon for a minute. While I've got 20 of you, we're not making a lot of progress on Pokemon, y'all. We're stuck. Are we still in Cerulean City? We were earlier today. Embarrassing. I want all of you. It's funny because we don't have as many users. So everybody put in 10 minutes, make the little guy beat some pizza, do a trainer battle, Appreciate you. I'll be back. Oh, Sea Fluff. You're one of the authors, I would imagine. Yes. Nice. Yeah, I'll get the VOD I just did of that in here. Yeah, right at the I'm like a good person to read this on stream, but right at the edge of my knowledge on a bunch of this stuff here. And yeah, very. I mean, I think we would be incredibly interested in doing an implementation of this. Yeah, I mean, either a Go or Rust sync engine for this is something that would work really well for us. And also, it's like if we can figure out the media mapping, it's like I don't know, like MoQ being the one transport protocol that we need in the world for all in the atproto universe, including if we do our jobs right for actual media transport. Very, very cool. I'm going to cut the